Did you know that an airline pilot receives a higher annual radiation dose than the average nuclear power plant worker? As a nuclear engineer, I've been a trained radiation worker for more than 25 years. And while I've always known that when on a flight you get a higher dose of radiation than normal, I never really knew how much. So I bought a plane ticket, and I grabbed my radiation detector, and I decided to go find out. So, how much radiation do you actually get on a flight? Where does it come from? And should you be concerned? So today we're flying to Orlando and we'll be in the air for about 90 minutes. As you can see on this radiation detector, radiation levels on the ground are relatively low. The dose rate here is indicating about 0.07 microsieverts per hour. Now the sievert is the international unit for measuring radiation dose, and really what it's telling you is the potential for biological damage from that dose. But in the United States, we tend to use the millirem. But luckily, it's easy to convert between the two because 10 microsieverts is equal to 1 millirem. Now you'll probably also notice on this detector that it reads out in microsieverts per hour. When we talk about radiation dose, we always talk about a dose over a specific time period. And that's because it's not just the magnitude of the dose that matters, it's also how fast you get it. So a high dose received over a short period of time has a higher potential for damage than that same amount of radiation given over a longer period of time. Now here we are at a cruising altitude of about 35,000 feet. As you can see, the radiation detector is reading significantly higher. So over the entire flight, the dose rate was about 0.7 microsieverts per hour, or about 10 times what the dose rate on the ground was. So that gave us a total dose of 1 microsievert, or 0.1 millirem, for the entire 90-minute flight. So, why do we get more radiation on a plane than we get on the ground? Well, the Earth is constantly being bombarded by cosmic radiation. In general, this is being generated from galactic phenomena like supernovas, or more locally, solar radiation generated by our sun. When we're on the ground, we're protected from most of this cosmic radiation by the atmosphere. But at cruising altitude on an airplane, there's just less atmosphere to protect you, and you're therefore exposed to more cosmic radiation. This is even more true for astronauts when they're in space, as they're not protected by the atmosphere at all. Okay, so now for the big question. Should you be concerned about this amount of radiation dose that you received on a flight? Well, not really, but let me explain why. The average American receives about 300 millirem per year of radiation dose from just natural background radiation. This can be from naturally occurring deposits in the ground, the granite countertops in your house, or from cosmic radiation. This changes based on the geology and elevation of where you live, but that is the average. So, the dose you get while taking a flight, even a longer flight, is significantly less than what you get just walking around and living your life. To put this into some perspective, a radiation worker in the United States is allowed to receive 5 rem, or 5,000 millirem per year, of exposure as part of their job. Studies have shown that the increased risk to these workers is relatively low when compared to the risk of other factors in life. And most workers do receive significantly less than that 5,000 millirem per year allowance, because we do try to minimize the amount of exposure that our workers get, in order to minimize the risk of any negative health effect. And even at the highest level of radiation dose I saw on this flight of 2.5 microsieverts per hour, or 0.25 millirem per hour, it was still well below the Nuclear Regulatory Commission's threshold that would even require posting of a radiation area in order to monitor exposure of workers. As another comparison, the amount of radiation dose you get on a flight is comparable to that of an X-ray. In fact, some X-rays give you quite a bit more than that. And yes, a long-haul flight would give you a higher radiation dose than what we saw on our test flight here, because your elevation is going to be higher, it's a longer flight, so you're going to get a higher dose rate, but it's still relatively low. One study I saw said that an average airline crew member receives about 300 millirem per year additional exposure just due to their job. And while any additional exposure does cause some increased risk, the risk is relatively low when you think about other risks in life. And really, that's what this whole conversation is about. There's nothing in life that is risk-free. It's up to you to be educated about the potential risks so that you can make the right decision on what to do. Statistically, driving to or from the airport is exponentially riskier than the little bit of radiation dose you're going to get on your flight. So, sit back, recline your seat 5 degrees, and enjoy your flight.